Martians might really exist in the future. But instead of the aliens of sci-fi movies, Martians would be humans, born and raised on Mars. And in this episode, you're one of them. Why would your skin be orange? Would you be a different species? And would you ever be able to visit Earth? This is What If, and here's what would happen if you were born on Mars. Some of our previous episodes have already looked at what it would take to live on Mars, but that's only half the story. To create a stable settlement on the red planet, people would have to start having babies. How many people would we need to create a healthy, non-inbred population? Well, some say we'd only need 98 people, but others say we'd need a minimum of 10,000. But regardless of the size of the breeding population, it would only take a few generations before we started seeing a huge difference between Earthlings and Martians. Mars is the most Earth-like planet in the solar system, but it's not exactly like the Earth. Its gravity, atmosphere, and magnetic field would create serious challenges for human life. And challenges often go hand in hand with evolution. Children on Earth are born with up to 120 genetic mutations. Move those babies to Mars, and they would start having mutations suitable for Martian living. And those mutations would likely pass on to their children. By the time we settle on Mars, we'll probably have the ability to modify our own genes, putting Martian evolution on the fast track. So, if you were born in the third or fourth generation of Martians, you would be a lot different than you are today. But what are the main reasons why your body would change? Well, first, there's gravity. Mars only has 1/3 of Earth's gravity, so your bones wouldn't experience the same force. Your bones would lose their density and become more brittle. Breaking them would become a common issue. Then there's the atmosphere. On Earth, you're used to a dense atmosphere that mostly contains nitrogen and oxygen, but on Mars, you'd be experiencing a thin atmosphere that's mostly carbon dioxide with only trace amounts of oxygen. You wouldn't be able to evolve a whole new respiratory system, but you could develop other ways of dealing with the lack of oxygen. Like you could have denser capillaries that are more efficient at moving blood and transporting oxygen to your muscles. But even with these advances, you'd still have to live underground or in a thickly insulated house to survive the harsh atmosphere. And since life on Mars would be confined to small spaces, Martians wouldn't need to be able to see far into the distance. Yeah, you would be born nearsighted. And finally, there's the radiation. Earth has a strong magnetic field that protects us from lethal solar radiation, but Mars has a weak magnetic field that's scattered along the planet. On Earth, our bodies produce melanin. It protects us from the radiation that does make it through Earth's magnetic field, but the radiation on Mars would be much stronger, and melanin just wouldn't cut it. Instead, your skin would produce carotenoids. This pigment would help protect you against skin cancer by slowing or stopping the cell cycle. Carotenoids can even make melanoma cells self-destruct. They're also what gives carrots their vivid orange coloring. Yeah, in other words, your skin would be orange. So, with all these changes to your body, would you be able to visit Earth? Well, Mars wouldn't have the same type of bacteria and viruses that the Earth does. So your immune system would be weaker than that of an Earthling's, which means Earth could be a dangerous place for you. And even if your immune system were strong, the gravity of Earth would be too much for your brittle bones. If you were born on Mars, you'd probably have to stay there. Humans have looked the same for a very long time, but within a few generations of living on Mars, we could have orange, nearsighted humans who could survive on less oxygen. And once we successfully settle on Mars, we probably wouldn't stop there. In the future, humans could have settlements on all sorts of planets, even outside the solar system. When it comes to planets in our solar system's habitable zone, one world is too close to the sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars wouldn't ever get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life. One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options to make it a place where humans could live. The idea is that we would explode thermonuclear bombs in the sky over the planet's 2 poles. This would heat up the ice caps and release carbon dioxide and water from the poles. Then the greenhouse effect would take place. It would heat up the whole planet, making the surface more habitable. So this all sounds super quick and easy. Why haven't we done this yet?
It's because there's a high chance that nuking Mars might not work out the way we want it to. There are many things that could go wrong with this plan. The first problem is it's all just theory, and the theory could be wrong. That's because Mars has been losing its atmosphere for a long time. Earth's atmosphere is almost 100 times thicker than Mars's, and if we're going to live on Mars, it needs a thicker atmosphere. Some scientists think that we could release CO2 from the North and South poles, and this could make Mars's atmosphere more like Earth's, but a 2018 study published in Nature Astronomy found that even if the nukes are successful, it would only increase Mars's atmosphere to 7% of what Earth has. Even if we create more carbon dioxide in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet. And the planet could seriously use more heat, since its current temperature averages around minus 63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. The things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea.
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door. Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars? Would you have to live underground? How many people would you live with? And what would the Martian economy look like? This is What If, and here's what would happen if we built a city on Mars. Since 1975, the only things from Earth making claims on Mars are robots and satellites. But now, Elon Musk and his company SpaceX are looking to change that story. Their goal? To create a city with a government, trade, and culture on Mars. This plan involves 1,000 spaceships and even more brave new recruits. By surviving in lower gravity with fewer people and only limited supplies, living on Mars might change how we could adapt to dwindling resources on Earth. But with so much depending on the early stages of planning and supply runs, could life on Mars be sustainable? Every great city starts small, whether you're talking about the little fishing town of Hong Kong or a hut village named Rome. So, if you want this Martian colony to grow into a thriving city, you're going to need more than a handful of people. According to the Bordeaux Institut National Polytechnique, you would need at least 110 settlers to start this adventure. The SpaceX plan starts with 2 spaceships carrying 100 people each. With this handful of explorers, your city would have just enough people to build more habitats and research stations without putting your resources in danger. If you run out of food at this stage,
that's the end of the experiment. The biggest challenge this city faces is becoming sustainable without relying on regular shipments from Earth, which will only come every few years. You see, with the egg-shaped orbit of Mars, it takes 687 Earth days to make one Martian year. Supply runs would only launch when Earth and Mars align, which happens every 2 years, to cut down on travel time between our worlds. And after this nearly 8-month-long trip, there's still a chance of losing all those supplies when the rocket lands. Since the gravity on Mars is only 3/8 of the pull on Earth, landing safely on the surface of Mars would be dangerous. And that doesn't take into account the amount of dust flying in the air. After all, the dust on the Moon was bad enough, and it got into crew members' eyes and damaged systems on their spacecraft. But kicking up the dust on Mars might be even more deadly, since each grain is highly oxidized and electrically charged. But hey, you made it to Mars safely. Now, what are you going to eat? The chlorinated soils on Mars are toxic, and if you ingested them with your food, you might damage your thyroid gland. So that means farming is out. Outdoor farming, at least. Well, before you worry about eating, you'll need to set up protection from the harsh conditions on Mars. With an atmosphere made of 95% carbon dioxide, the air on Mars is toxic. And don't forget about the intense radiation on the surface. With more exposure to radiation and no breathable air, you won't be able to survive without a controlled environment. Thankfully, with the help of those rocks under your feet, you have all the protection you need. Just 5 meters of the surface materials on Mars, called regolith, provides the same amount of shielding from radiation as Earth's atmosphere. This material would be processed into cement to create layered walls using robots and 3D printers. This material would be a protective shell, and underneath that shell, domed science facilities, living spaces, and all your home comforts. Connected by tubes, these domes would provide you shelter from the raging dust storms outside, which might last for months. Even with this technology, Elon Musk claims it could take up to 10 years to establish a colony. But it's during this time that your quaint Martian village would grow into the first human city beyond Earth. Since this world isn't being drilled or fracked, the power grid on Mars can be made sustainable right from the start. We would set up solar arrays for electricity and use natural gases like methane for engines. Our footprint on Mars could start low and stay that way, no matter how many people live there. And now you better figure out a way to feed all these people. The low gravity on Mars might decrease your muscle mass. To keep your body healthy, you'll need to provide more protein. You'll have to serve the equivalent of 110 cooked chicken breasts and 660 carrots every day. If one of these domes contained an indoor farm, you could raise the chickens you need to feed your city. And you would have the most nutrient-rich manure available. If you used this manure in the greenhouses, you'd have a way to fertilize your crops year-round. But how could you irrigate those crops? How would you get water? Scientists still debate whether liquid water exists below the ice caps on Mars, but if it does exist, that freshwater source could be filtered for the colonists to use for irrigation. With less gravity on Mars pulling water down into the ground, you would need less water to keep your plants alive than you would on Earth, since it would stay closer to the surface. And with supplies being transported only every 2 years, having spring water available on Mars would change how the city would operate. It would create a government infrastructure to distribute and oversee the water supply and employ scientists to manage the filtration needs. Now, the city has an infrastructure in place and jobs to fill. So, how would you value your time in terms of cash? How could you pay for products or services? Cash weighs too much to travel with in outer space, and credit cards would require Wi-Fi services communicating back to Earth. With a 14-minute gap in communications between Mars and Earth, you're gonna need something more locally based. Well, you might have to use a cryptocurrency known as Mars coin, but you would have need to have bought it with your Earth money before you boarded the spaceship. While Mars coin would only be available to Martians, this money would help build the government, increase trade, and create a standard of living. With society on Mars still new, maybe you could trade your services or learn to barter goods instead of relying on this cash system. If we do things right, life on Mars might be the model for future civilizations, free from the constraints of the culture built on Earth. Or it could be like every sci-fi movie ever made. Thanks, Jupiter. If you were to drill straight down into Mars, what would you find? Would the red planet reveal its true colors? Would you finally discover life on Mars? And how would drilling through Mars compare to drilling on Earth? This is What If, and here's what would happen if we drilled through Mars. This is the Jezero crater on Mars, and 3.5 billion years ago, it looked very different. It used to be an ancient river delta that carried clay minerals into the crater lake. It might have even hosted Martian life. Fast forward to now, and the Jezero crater has become a perfect landing site for NASA's shiny new rover. Meet Perseverance. If I were to search for past life forms on Mars, this is the place I'd start looking too. Only instead of collecting rock samples, I'd send a rover to drill through the surface. What's the worst that could happen? Did you know that Mars has Marsquakes? They're like earthquakes, but on Mars. NASA's Martian lander called InSight detected 480 of these Marsquakes in 2020 alone. Luckily, there isn't much out there to damage. For us, these Marsquakes are a good thing. They create seismic waves that our scientists can study, and based on these studies, they can theorize about the Martian interior. But you and I would be doing this the hard way. We would drill through Mars to see what secrets it holds inside. If you started drilling through the reddish iron oxide abundant surface layer of Mars, the first thing you'd discover is that the interior is not so red. But don't be surprised. In 2012, NASA sent the Curiosity rover to Mars. It landed about 3,700 kilometers from the Jezero crater. Curiosity discovered that the layer beneath the surface of Mars is slate blue? Yeah, that's because it contains high levels of silicon. Huh. And as you drill, you should continue to expect the unexpected. The next discovery you'd make is that the crust layer on Mars is thinner than the one on Earth. Remember InSight? This little lander indicated that the Martian crust is only around 20 or 37 kilometers thick. Compare that to the Earth's crust, which is approximately 40 to 50 kilometers thick under the continents. If water still exists in liquid form on Mars, it could be several kilometers inside this crust. And there are radioactive elements in the liquid mantle below the crust. These elements release geothermal heat through their decay, and it should be enough heat to melt thick sheets of subsurface ice. This geothermal heat could be why there was liquid water on Mars 4 billion years ago, even though the surface temperatures were below freezing. But enough theory, let's keep drilling. boring through Mars would be even harder than drilling through Earth. The deepest we've ever drilled on Earth was 12.2 kilometers into its crust, and that came with high budget costs, technical difficulties, and plenty of bad luck. But on Mars, this would be an unimaginably tricky endeavor. The InSight lander tried drilling, but it encountered unexpected soil properties. The drill probe was trying to go 5 meters deep, but could only go a fraction of the distance before popping out. Then there was Curiosity. It experienced a mechanical error. The drill feed mechanism that was supposed to move the drill bit forward wasn't moving when commanded. Luckily, scientists designed a new, more human form of Martian drilling. Now, the rover uses the force of its robotic arm to push the drill bit into the surface as it spins. But don't get your hopes high about reaching the mantle of Mars too soon. It took Curiosity the entire day to drill a mere 5-centimeter hole. Based on that, going 5 kilometers down would take up to 300 years. And you'd need a bigger drill. There's still so much we have to learn about Mars, but maybe drilling isn't the most effective way to do it. Especially since we haven't gotten very far into the crust of our own planet. Congratulations! You've taken the 7-month-long journey and have finally landed on Mars. And it turns out, you're the first person. Better start cleaning the place up and getting it ready for human colonization. Will you ever make it back to Earth? How will you gather resources for survival? And will this happen someday? This is What If? And here's what would happen if you were the first person on Mars. A trip to Mars might happen sooner than you think. NASA is hoping for it to be as soon as 2033. Think about that. The first person on Mars might be watching this video right now.
Hello, future Martian.
And NASA may not be the first to get there. There are plenty of other space companies trying to get to Mars around the same time. Similar to what we saw in the 1960s with the Moon, it's very likely that we'll see another space race, only to Mars this time. But getting there is the boring part. Now that you've landed, what happens next? Your first goal will be to set up base. And it can't just be anywhere. Researchers believe that the best place for a camp on Mars is near the planet's poles. There, you'll find massive ice deposits, which are thought to contain large amounts of water. We need water to survive, but it's heavy and it takes up a lot of room on a spacecraft. So, to solve this problem, we could potentially turn this ice into water that we could drink, study, and use. Scientists suspect that the ice deposits may also contain iron and sulfur, which could be used for manufacturing in the future. But that's in the long term. For now, let's worry about your base being built. Luckily, you won't be building it, as space companies intend to send a team of robots up there to assemble the base for you. After that's done, you can finally move in. The base will be roughly 12 meters high and 5 meters in diameter. That may sound pretty roomy, but you won't be alone. Space companies are planning to send 6 people to Mars for the first expedition. At least you'll have people to talk to while you're there. Once you've landed, you'll quickly notice how different Mars feels from Earth. Mars has just 1/3 the gravity that the Earth has. NASA says that a person who weighs 45 kilograms on Earth would only weigh about 17 kilograms on Mars. You'll be able to jump all around the planet. But if that's all you expect to do, this trip won't be for you. The first people on Mars will be unlike any astronauts we've seen before. Apart from knowing everything about physics and spaceships, they'll also have to be farmers, botanists, and excellent problem solvers. One massive problem they'll all need to solve? Food production. Let's hope you like your vegetables, because aside from astronaut food, that's pretty much all you'll be eating. A university in the Netherlands simulated crop growing on Mars and found out that potatoes, peas, carrots, and radishes could all grow on the planet. You'll be able to use the soil on Mars, and water will come from recycling urine and whatever other water products were brought onto the planet. And speaking of human waste, unfortunately, you'll have to use your poop to fertilize the crops you're growing. Now that's recycling. After about 9 months of researching, farming, and exploring Mars, you'll then begin your journey home. This is arguably the hardest part of the trip. You and your crewmates would hop into this Mars Ascent Vehicle, or MAV for short. Then, you need to line it up perfectly with the larger spaceship, which is orbiting Mars. The ascent up to your spaceship could last as little as under a half an hour, or it could be several days. It all depends on whether you can line up the MAV with the larger spaceship. And if not done correctly, things could go very, very bad. But if all goes according to plan, think of what you've just done. You were the first person on Mars. And after living there for months, what you've learned will make it easier for future generations to live on the red planet. Permanently. Did you know that Mars has polar ice caps just like we do here on Earth? With the right technology, they might be our water source should we ever move to the red planet. But in their current state, these caps could be a source for extreme interplanetary sport. Want to ski on snow unlike anything else in the universe? Want to test your skills on the biggest mountain in the solar system? Bring your 80s snowsuit if you must. Just be sure to pack a good helmet. This is What If, and here's what would happen if you could ski on Mars. Even though Mars is much smaller and much colder than our planet, its abundance of water ice makes it a compelling option for life on another planet. And with the concept of a future Mars colony gaining popularity, homes on the red planet might soon be on the market. If we do end up living on Mars someday, what would we do for fun? Technology will have advanced, so there'll be a lot on offer. But what about the classics, like enjoying the great outdoors? Could we go skiing on Mars? Lucky for you, Mars is home to the highest mountain in our solar system. Olympus Mons is a shield volcano that's 21,000 meters tall. That's more than 4 times higher than the highest ski slopes on Earth. But if you call yourself a black diamond devil, then this isn't the hill for you. It turns out Olympus Mons is more boring than the Bunny Hill. It has an average slope of just 5 degrees. And considering that Martian gravity is just 1/3 of what we experience here on Earth, it might take you a while to get started. On the flip side, because of that weak gravity, you could jump 3 times as high. So this could be this. Let's not get ahead of ourselves. We haven't even started moving yet. With an average temperature of minus 60 degrees, it's definitely cold enough to snow on Mars. But considering its dry, low-pressure atmosphere, snow barely reaches the surface and never stays for very long. That said, Mars does have 2 poles that consist of water ice and carbon dioxide, which in solid form is dry ice. And at Mars's south pole, there's a dry ice deposit that's 1,000 meters deep. But before you give it a go, it's important to note that the friction from your skis will heat up the dry ice and turn it into a gas, causing you to lose control. If you really wanted to, you could try your luck on the water ice, but its density brings it closer to the ice skating conditions you'd find on Earth. So why use a flat ski when you could go further with a sharp blade? Then again, there's more than one way to ski, so if you're that determined to make this work, then just slap on some hard wax and take things cross-country. Or is that cross-planet? Whichever style you choose, it's a double-edged sword. Shorter and thinner skis are your best bet for reaching fun speeds, but they're also going to have to support your clunky space boots. And if you don't get the balance right, well, you had a good run.
Mars didn't always look like this. It may once have been covered in oceans. But what if we brought all the Martian water back and transformed the red planet into one that's half blue? What would Mars look like if it was 50% land and 50% water? Where would we even find enough water to fill Martian oceans? And why might we have no choice but to nuke the red planet? This is What If, and here's what would happen if Mars was half land and half water. Long ago, Mars could have been covered by a massive ocean, and there may have been rivers, streams, and lakes spreading out across the planet too. It might be that billions of years ago, Earth and Mars had similar climates. Except the Martian ocean covered only 20% of the planet compared to Earth's 71%. And the surface temperature was a bit cooler. All of that thanks to an atmosphere that didn't stick around long enough. 4 billion years ago, Mars lost its protective magnetic field. And the solar winds started to carry all of its atmosphere off into space. A few 100 million years later, Mars changed from a warm, wet world to what we know it as today. Cold and dry. Only 18% of its ocean remains, trapped in frozen polar ice caps. So, if you wanted to turn Mars into a half-land, half-ocean kind of planet, you'd need to add a whole lot of water. Unlike Mars, most of Earth is covered with oceans. So, what do you say we donate some of that water to our red neighbor? Well, let me tell you, that's a very, very bad idea. To make Martian oceans as deep as Earth's, you'd need to ship out about 20% of our ocean water. And this would suck for our marine life. Yeah, leave the Earth's oceans where they belong. Besides, there are a few other places in the solar system where you could find water, like Saturn's moon, Enceladus, and Jupiter's moon, Europa. They might have twice as much water as Earth, but to transport some of that precious H2O, you'd need to move massive ice blocks through space. This would be difficult to pull off, to say the least. You'd need rockets capable of transporting huge amounts of weight, and you'd need money. Yeah, a lot of it. 'Cause the price could be as high as $1,500 per kilogram. And considering how much water you'd require, well, the final price tag for this operation would be well into the trillions. Yeah, expensive, I know, but there might be another way of bringing Martian water back. And you'll love this one because it involves nukes. Yeah, you heard me right. You're about to nuke the red planet. And yes, this would give it some water. How? Well, all that energy would release frozen Martian carbon dioxide. This would cause temperatures to climb and thaw out the poles. It would be kind of like causing controlled climate change. Only you'd need to detonate around 3,500 nuclear bombs every day. And this would mean shipping twice as many bombs daily as the United States currently has in its entire arsenal. That's an enormous amount of radioactive material to release. And it wouldn't exactly make Mars habitable. Plus, you'd still need a lot more water to cover half the planet in oceans. Okay, it seems like nuking everything in sight isn't the best idea. Maybe you should take a little planetary history lesson instead. About 4 billion years ago, during the late bombardment period, a non-stop barrage of asteroids collided with Mars. This created enough water to eventually make an ocean 300 meters deep. So all you'd need to do is recreate this event today. You'd have to redirect at least 1 million comets and meteors so that they'd end up on a collision course with Mars. As the comets crashed into Mars, they'd burn up and release water vapor. Rinse and repeat until you get enough water to cover half the red planet. But where would this water go? Well, looking at Mars's topography, you'd find that all this new water
would settle mostly above its equator.
Mars would have new land masses that would look like continents. There would even be mountains sticking up on some parts of the planet. Olympus Mons, the tallest volcano in the solar system, would now tower high out of Mars's new northern ocean. But just because you were able to bring enough water to cover half the planet, that wouldn't mean it would last. Because of Mars's low atmospheric pressure, all this water would easily boil away. Well, wait, how would it boil away if water's boiling point is 100 degrees Celsius? Aha, well, that's the boiling point on Earth. On Mars, the water would start to boil at 0 degrees Celsius. That's frustrating, especially after all the work you put in bringing all this water to Mars. You'd have to hope that this water vapor would work as a greenhouse gas. If it could trap enough heat in the Martian atmosphere and turn Mars into a lush, terraformed world, maybe then you'd be lucky enough to be the only Earthling ever to go for a swim on another planet. Scientists theorize that many millions of years ago, Mars had rings, just like Saturn. And it looks like the red planet could be due for a new set of rings in the future. How exactly would this happen? Would these rings clutter up Martian orbit? And how soon would these new rings start raining down on Mars? This is What If, and here's what would happen if Mars had rings like Saturn. The 4 gas giants in our solar system, Jupiter, Uranus, Neptune, and Saturn, all have ring systems surrounding them. Of those, Saturn has the largest. And Mars could join the club. Scientists studying Martian moons Phobos and Deimos suggest that Mars could have had several more moons, including one up to 20 times larger than Phobos. Over billions of years, these moons could have been destroyed and become part of an ancient ring system. Could Phobos and Deimos be next on the Martian moon chopping block? Phobos is orbiting Mars only about 6,000 kilometers from the planet's surface, and it's slowly losing altitude. Eventually, it will reach the Roche limit. This is the closest a big space body can come to a planet and still be held together by its gravitational forces. For Phobos, the estimated Roche limit is 5,470 kilometers from Mars. At this point, the tidal forces of Mars would start to pull the moon apart. After breaking into carbonaceous chondrite meteorites, the stony rocks and dust would form a thin, dark ring around the planet. You'd find that the smaller Martian moon, Deimos, would still exist. That's because it orbits Mars from a comfortable 20,069 kilometers from the surface. Deimos would now mark the outer edge of this new ring. This dramatic reshaping of objects in Mars's orbit could have a big impact on any plans you could have to leave Earth and settle on Mars. Well, maybe not your plans, but more like the plans of your future descendants. Scientists expect that Phobos won't get ripped apart into rings for about 50 million years. The development of rings around the red planet would be a challenge for space flights. It would be difficult to navigate or transport people and resources. Even the most routine trips on or off Mars would become hazardous rides. And a ring system would block some sunlight, having huge effects on our human settlements on the surface. Mars is already a frozen planet with an average surface temperature of minus 63 degrees. So things would get even colder. Let's hope your descendants brought enough warm spacesuits. And even more danger would lie ahead. Eventually, all the objects in the ring would come crashing down on Mars. Big rocks would leave massive new craters on the planet's surface. If it's anything like what happens on Saturn, Martian settlers could face massive storms of rock and dust, falling to the surface at 10,000 kilograms per second. The future of humanity would depend on our ability to create new technologies to blast apart these falling objects before they crush us. Luckily for us, this would happen sometime between 1 million and 100 million years after the ring forms. Yeah, we'd have plenty of time to come up with a solution. Maybe we could just nuke all those space rocks before they crush our Martian dream. Well, that's a story for another What If. Martians might really exist in the future, but instead of the aliens of sci-fi movies, Martians would be humans born and raised on Mars.